Hello everyone, welcome back to the channel. In today's tutorial, we are going to create a beautiful animated NDVI time series of Pakistan using MODIS satellite imagery in Google Earth Engine. Instead of creating a single NDVI map, we will generate an animation that shows how vegetation changes throughout the year. So let's get started. So that's mean a new NDVI image is available approximately every 16 days. Since we are interested only in the vegetation, I am selecting the band NDVI. So what is the next step for that? Our next step is the study area. Now I need the boundary of Pakistan. Instead of importing a shapefile, Google Earth Engine already provides an international boundary. This saves a lot of time because we don't have to upload administrative boundaries ourselves. And then we have applied this filter function. I'm here filtering the collection. The country code PK represents Pakistan. Now only Pakistan's boundary remains in our feature collection. We will later use this boundary to clip the NDVI images. You can use your own country code over here. Then we have a region. I'm defining the animation region manually. This polygon covers the entire country. Google Earth Engine uses this region while generating the GIF. If we don't specify a region, Earth Engine won't know which area to animate. Okay, these are the coordinates that simply define the western, eastern, northern, and southern part of the Pakistan. So if you are working on another country, you can simplify replace these coordinates. You have to replace this for your own area. Okay, our next step is this. And now it comes an interesting part. We are going to add a new property called day of year oven approach. Okay, we are going to add a new property called day of year. For example, January 1st is day 1, February 1st is approximately day 32, while the December 31st is the day 365. That's how it works. So this variable is something that every MODIS image already store in acquisition date. Using the system.timestart property, we extract that date. So finally, we save a new image property named DOI. Here I am selecting only 1 year because I only need one example of every day of the year. Think of this as creating a calendar that contains every MODIS acquisition date during 2013. We will later match all other years to this calendar. Now I will use another function that is called the filter. What will it do? This filter tells Earth Engine to match images that have the same day of the year. For example, all images captured around day 150 from every available year will be grouped together. This allows us to reduce seasonal noise while preserving the vegetation pattern for that specific time of the year. And then our next step is join. What this function actually do, a join works very much like joining two tables in a database. Instead of matching the rows, we are matching satellite images. Every reference image will store all the matching images having the same day of the year. And then we have another function that is a variable that is named as a join call. So each image now contains a list of all corresponding images from different years. So this grouped collection will be used to calculate long-term NDVI median. So this is another variable. Uh, Next, we create the composite. Instead of keeping every yearly observation, we will calculate the NDVI median value for each day of the year. So that's why we have used this function. So we have make a variable that is named as a toy call, and this convert the started image list into a normal image collection. Then we have a return function, and what we'll actually do, finally we calculate the median NDVI. Median is commonly used because it removes outlier by clouds, haze, and abnormal observation. The result is smoother seasonal vegetation cycle. And next we have visualization parameters, like how we want to see NDVI on the map. So these parameters only affect the visualization. They don't change underlying NDVI values. So next step is to create the animation. These are just visualization parameters. This is the process of creating the animation frames. So now we are converting every NDVI image into a colorful visualization here. And then we have war GIF parameters. We have selected some of the parameters in here. While we have region, this tells Earth Engine where to create the animation. Like it's my region of interest. Then I have dimensions and that control the output size. Then I have the CRS. CRS specifies the map projection. EPSG 3857 is a standard web Mercator projection used by most online maps. And then we have another frame per second that control the animation speed. Higher values make the GIF play faster. And finally we have a GIF URL. This line generate a URL for downloading the animation. When I run it, you will see like we have a link and it's creating a thumbnail. So when this is the final GIF that looks something like that, and when I open this, so this is how the URL link look like, and this is how our animation look like. So let's increase the date to make it more useful. For example, I want to create it from 2002 to 2014, or you can increase it to 2020. Okay, in this tutorial, we learn how to load MODIS NDVI imagery, define a study area, add a day of the year property, group images from multiple years, calculate median, seasonal composite, apply a color palette, and generate an animated GIF that visualize vegetation changes over time. So if you enjoyed this tutorial, please like the video, subscribe to the channel, and let me know in the comments what would like to learn next. In upcoming videos, we will explore time series analysis, drought monitoring, land cover changes, and advanced visualization techniques using Google Earth Engine. Thank you for watching, and I'll see you in the next video. Bye.